Hello, hello. I hope you are doing well and starting out with a solid beginning here to Python Absolute Beginner Module 1. We have done tasks 1 through 12 at this point. And so if we review and we go back, we'll see we ended with a little bit of character art, so drawing things. We had also learned about the print statement. We had learned about some data types. Particularly, we had learned about strings and integers and decimals and how to use them with variables and do a little bit of manipulation like addition, and then print them to the screen and look at the errors if there are errors and understand them. This is the longest module in the tutorials for Python Absolute Beginner and Python Fundamentals. It's the longest. This one gets you started, and so hang in there. As you're learning, remember what you're learning. You're going to apply it in the practice notebook that's coming, and we're going to get through Module 1, and by the time you finish Module 1, you understand the basics of the most fundamental programming paradigm called procedural programming, where you write down a procedure, kind of like writing down a recipe for a standard recipe for food, and how you have the instructions all in order, one after the other, chronological by what you do. Well, that's procedural programming. So that's what we're learning here. So let's keep going. Some of the fundamental things you want to do in programming: you want to be able to send output, you want to be able to get input. Now, our input has been directly into the code. We haven't had any kind of user interface. So any input we get has had to come through our code directly. We don't want normal users to have access to our code directly. So we need methods that present a user interface for receiving input. There is a simple function in Python called input that is a shortcut for doing this kind of thing. Realistically, user interfaces and input come from web pages, or they get passed to us from other computer systems through web services or direct inputs. They come from databases. They come from full graphical user interfaces. We're going to see examples in our demonstration projects of all of these kinds of things this semester. But we're just starting with our coding. So we're going to use this easy one, input, as a way to start understanding how we can prompt a user. In this case, it's going to be us prompting us, but it could be us prompting someone else to give us some information that we'll then process and output in some way. So let's jump ahead and see how this goes. So input is a function. It's built into Python 3. And if we run this example, just looking at it, it says print enter a small int. Then it says small int equals input. So if I go down here and I hit return, I see an instruction that says enter a small int. And then I see a box with a blinking cursor. And so if I put 4 and I hit return, it says small int, small int. Isn't that interesting? So int meaning integer here. What's also interesting is this prompt for the user can actually be put somewhere else. So if I were to take this like this and put this down here like this and capitalize it, and I like having, maybe I want to say the whole thing just in case the user doesn't know what my short form here is. Now if I run it again, do you see that on the same line as the input statement now I have the prompt, and then I have the input box, and I can type in and it puts it out. So there are a couple of different ways to do these things, and you can see it here. I'm going to put it back to the way it was, but there it is. Okay, and so here, get input for the variable student name, and then it says go ahead and press enter, and this time we're going to store it in something like student name equals, and I'm going to go ahead and type this one out for you to see. Input, please give me a student name, colon, a little prompt there, and then print student name type is plus type student name. Let's see if that works. So Jim. Can only concatenate strings. So I have to make this into a string. You're going to see this later. I'm going to turn this into a string by using the str, string function. And did I skip a, I did. I skipped a parentheses right there. So see how the errors are helping me out? And now I'll type Jim. And it says student name type is string. How about that? And by the way, check this out. What if I come down here? Now notice the next task, it says input returns a string regardless of entry. So even if I put a 4 here and hit return, the input box always returns a string. So if I need this to be something other than a string, I'm going to have to do something called casting, which we'll be learning about. That's what I did here. I used this str function. And on our cheat sheet, you can see that there are functions like this. So we can actually see some built-in functions over here on the cheat sheet. And you see the str function there. And there's an int function. There's the type function. So input is one of these functions. It's not listed here because it's so common. And print, of course, is another one. So there are a bunch of built-in functions. We've just started learning a few of them. Your cheat sheet has examples of more of them. And of course, you can look them up online. So you can do this and fill that variable with a student name, and then you'll see what the type is. You'll see that it's a string. So input always gives you a string, and then if you determine the type of various inputs, you can try it with an integer, you can try it with a float. It doesn't matter. It will be a string when you do that. So you can go ahead and run this cell several times and try it out. And the reason to do that is so that you can then really remember this point, because it's quite important. It can cause you problems in your code later if you forget. Okay, so here you see that the input statement has an optional string argument, which is the prompt to the user. There it goes. We've seen that. I just showed you an example of that before, so I can go in here and say Dominic and hi Dominic. So we can see that this prompt showed up, and then I was prompted to fill in my name. Down here, go ahead and I think you can do this task. Should be fine. Down here, we could make multiple prompts. And this one, so create variables to store name, age, get mail. So actually, we see the examples here, and we can then just type it in, equals input, and then we need to tell them something. So please enter a name. So maybe we're writing a form for a mailing list for our website, and these are the things we're going to need. And we would do the same thing. Please enter your age. Age, you might think, well, we can't do that. We can't ask for age. Well, sometimes you have to. Some laws require on a website, for example, that you only provide certain kinds of access or services to people of certain ages. For example, when children are under 13, there are much stricter rules, and there we go. And then we'll tell them to enter yes or no. Like that. And if we test it out, we see it says enter a name. I can put in a name. I can put in an age. And yes. Now all of that is in memory. We see that the cell is done. It ran. But down here, we don't actually see the results. So I would have to go back here and finish the rest of this cell to print out the statements with each of these things. They're in memory already because I ran it. Or I could just run it again and fill it in again. So I think you can do that and get familiar with this input statement. All right. So numeric addition, adding a couple of numbers, it'll put out the sum. We've also got what they're calling string addition, which is also called string concatenation. There you see that phrase show up. As long as you've got two strings, you can do that. We can also add variables of the same type. So down here we can see a couple of numbers. We've kind of seen these things before. We can see that we can put two strings together. Down here, if we put a variable in a string, that works too. So I think you're ready. We've seen these tasks, and this is just repeating to get you to really seal it in. So go ahead, fill it in there, and you should be fine. Let's come down again with print. So print does more than we've seen yet. You can actually do a bunch of things with print. So for example, we've seen we can take a variable and fill it with Colette as a name, and we know that we can do string concatenation where we actually put in, you know, hello plus name plus exclamation point. Well, it turns out that the print function can take a series of arguments. So it can take a string, and then you put a comma, and then you feed it another argument, in this case the name variable, and then a comma, and then we give it another string, and it's going to automatically put a space between each argument. So watch this. I'm going to put a period here so we've got good grammar. And I hit return, and notice hello to, and there's a space here, Colette. Do you see? There was no space here. When we use string concatenation, we have to intentionally put the space in, but when you use a comma, it automatically puts in spaces and puts the string in that's being held by the variable. So here you can do that. You can test that out. Just go ahead and make a print statement, and then make a sentence, split it into 3 separate strings, hit print, and see how it all comes together. Pay special attention to what I was mentioning there about the spaces. Okay, so strings and numbers together, this is kind of cool. So here, if we go ahead and run this example, you can see that when you have strings and numbers together, the print function will automatically do the typecasting for you. It will convert this integer into a string. Because we know if we were trying to do this, what if I did this? I tried to use string concatenation with an integer. Then I get a type error that says I can only concatenate a string, not an integer, to another string. So the nice thing about the commas is that the commas cause the print function to do the type sensing and then the type casting to a string for us. It saves us that step, makes life easier. Again, down here, same thing. We can use that even with a variable that's got an integer or a float, a decimal in it, and it will work. So if you run this example, you can see that it worked just fine, no type errors. All right, so here, combine two numbers, two strings, use commas. I think you're ready for that. Down here, so here, print comma separated, mixing of strings and variables, display text and address made from strings and variables. It's a very common sort of problem to deal with in an online store or something like that. We've got to ship a package to a customer and we need to verify their address to them, and so we grab the various types of data and we pass it to the screen to show them their data. And so what you're learning here is to be sensitive to data types and to how they can be used and what you need to do to present them to a user in their different formats. Down here, similar, 18, define a variable with a string or a numeric value, display a message combining the variable and one or more strings and a number. So no problem. Just more practice of the same kind of thing. Finally, at task 19, we're actually getting to a simple program. This would be like a check-in program. You can imagine a kiosk at a training center, of some sort. It could be a special workshop we run at the university, or it could be in industry. But you can start to imagine. So get input for the variables. We're going to work through this whole example together. We're writing a whole program here. It's short, but it's a real program. So input. So here, owner. Name of the person, owner of this reservation. And the real instruction I should probably put. So I'm trying to think through what the user needs to see. Please enter the name of the owner. Writing the instructions for user input is really important because you want to get accurate information from the user. So input, please enter, enter the number of people on attending. Okay. Input, please enter the class time you want to reserve. All right. Create an integer variable min early and hard code the integer value. Okay, so create an integer value. So reading up here, reading the instructions is useful. Number of minutes early the party should arrive. Minimum early will be 5. There we go. And hard coding means we're putting it here. It's not subject to user input. Print reminder using all variables and add additional strings using comma. Okay, so remember, something like this reminder phrase could actually be sent via text message or something like that. Once we've created it, we can send it to the screen, but we could also schedule it to send later or all sorts of things. So I'm going to take this example and I'm going to drop it right here. And then I'm going to do print like this. And I see this 10 minutes early is really my early time, right? So I might as well do min early. Training is scheduled at, and here I can see that what's happening is scheduled at training time for the, and this is going to be the training owner. group of, and here I want to put in the attendees number. Put in my commas and num people and period and close my quotes and close my parentheses. And down here, do I have any trouble? Nope, looks fine. And let's run it. So name, number of people, and keep going, number of people attending, 23, and class time, 2 p.m. And reminder, training is scheduled at 2 p.m. for the dominant group of 23 attendees. Please arrive 5 minutes early for the first class. And I'll put a little period in there. There we go. So you see how we created some basic logic that actually serves a full purpose in terms of our code. We've got the ability now to make a full logical program that takes several inputs, processes them a little bit, and then presents them to the screen. Assign a string value to the variable first name, add the string, remember to save notebook frequently. So here's another one that you can put in. I think you can handle that easily. And so down here, if we keep going down, we can see some more examples. So here's Colette. We've actually seen this task, just more practice. You can run through that here, do 3 strings, you can do that. I want you to really understand how this whole process works. So go ahead and you can run these examples. Here, 2 numbers, 2 strings. Down here, input for a street name. I think you can do that, run that again. And down here, we got more that you know how to do. The training, this time you've got a clean one, you can run through that. Let's go down and take a look. Let's see here. Quotes inside of strings. So sometimes you may want to present the user with, for example, a contraction, it's, and we have a problem because we can't have unbalanced quotes on the outermost level of the string definition, because otherwise Python will think we have a syntax error. So look closely. There's a concept here which is outer quotes and inner quotes. So if we want to put some double quotes inside, if we want to say like this, I said to the class, sometimes you need to shut down and restart a notebook when cells refuse to run. And we'll put a period there. Okay. And we'll put a period here. In order to make this quote show up inside of the string itself, we need to use a different pair. So that's nice thing is we have single quotes and we have double quotes, and either one can designate a string. But if we want to use double quotes inside of our string, then we need to define our string using single quotes. And so if I run this cell, you can see that it works. You can see that my contraction with the one single quote here worked just fine. Or apostrophe, you might be thinking of it as an apostrophe, that's fine. But it's single, it doesn't have a pair, and it didn't throw an error. There's no syntax error. On the other hand, my double quotes also show up here, and they show up because I encapsulated my string in single quotes. And so Python was able to process the fact of the first and last single quote, and it made everything in between into the string. So that worked just fine. So I think you're ready. You can do this part. You can display the text, where's the homework? So you're trying to get this apostrophe or single quote to show up. And then you're also going to output with double quotes. So you're going to try to print out this phrase and just follow the examples we just did. And you should be just fine. Now we're about to get to one more processing piece here that really puts you at a place where you can do some fairly powerful things. You may not realize it yet, but you can. And it has to do with what our string data primitive can do with its own properties or methods. And these are cool. So notice the word method. This actually, there it is. Sorry, I double clicked so it opened up. A method is a set of functionality built into an object. Now, we haven't really talked about objects, but a string is actually an object, so it is a definition that includes some data properties like its actual value of the string, and then it also includes methods, which are things you can do to that string. And if you were to look back over to our cheat sheet, so if we went back over here, we'll see there's actually a whole section on the backside called String Object Methods, popular. And there are a bunch of them here. And notice things like is all num, true if the string is all numbers and letters. Is alpha, true if all alphabetical letters. Is digit, true if all digits and not spaces. Is numeric, true if all numbers. So that's what we're looking at here. We actually have methods where we take the string and we put a dot, a period, and then we type is alpha with parentheses. So this is like a function that is specific to a specific string. Remember, functions are things like print or input or type. Those are built-in functions. Well, a method is a function that attaches to a specific object. So in this case, for example, we know that we can put a phrase into double quotes and make it a string. So hello is a string. And it turns out we can use this method to see if this string is all alphabetical letters. So we can use is alpha. And what happens is there's Python code built into Python 3 that will go through and check if every character in the string is just an alphabetical letter and not a number or punctuation. So down here, if I do Python is alpha, it says true. If I do third is all num, it says true. But if I do third is alpha, so if I change this and I run it, I get false because the 3 is not an alphabetical letter. It's a number. So all num means either number or letter. If I do a cold stormy, look at that, stormy night, and I run it, I get true. If I do is upper, so title case checks to see if the first letter of every word is capitalized. In this case it is. Is digit says true. So inside of, remember this is a string, and only strings have this is digit test. If I were to make this into an integer and run it, I get invalid syntax because the integer doesn't have the is digit test. Doesn't need to. We know if it's an integer, it's definitely already all digits. CM height ones, so we can run these on, so if we have a variable filled with a string, we can still run this test. So we can run it on a variable too. Look, we just take the variable name and then we run is digit. And that saves us from typing in 176 twice. It also means we can test user input to see if they gave us a number. We'll be doing that later. So then here we can run this example and we see save is lower, false, save is upper, true. And then there's this another one here called starts with. It's kind of cool, and it checks if the first letter is a B, a capital B, and it is. What if we do a lowercase b and it is not? So play with it. You know, think of, you've got some power here to be able to test things and to then send output of a result. So what have we done? We know how to get input. We know how to do some processing like these tests, like concatenating strings, like simple addition. We're going to learn more about all of that and how to get much more sophisticated. You can already imagine if we have plus, we must have minus, we must have multiplication, division. Absolutely. Not only that, we've got way more than that. We can run all kinds of mathematical operations, etc. So we can do input, we can do processing, and now we can also output an answer or a result from the processing back to the interface, to the user. So we have all the components necessary to write a procedural program that does real things, even right at this moment. Okay, so I think you're ready to do task 26. If we go down here, we've already seen about single and double quotes. Roll back through these, do them one more time just to cement it in. You've seen these methods and tests. Here's a clean copy. Run back through those, think through them. You can see how isAlpha works. Try something other than isAlpha. Use allNum or try starts with, so that you get it to be solid in your memory, so that you know what's going on. So now let's keep rolling down, and we see that we've got some other kinds of methods. We have formatting methods. So those methods we saw earlier are what are called boolean test methods. Boolean is just true or false. And a boolean test method puts a condition onto the string that results in a true or false assessment. So whether it's all digits or all alphabetical letters or starts with B. Well, what these formatting methods do is they actually change the string itself to become something different. So you can see we can have a string that's sort of, see there, dot capitalize. Capitalize will capitalize the first letter of a string. And what's interesting is that it'll actually reverse this one. So what if I had a lowercase b here and I run it and I see I've still got Miss Browning? It actually took it out. What if I take this period out and put a B and hit return? So you can see how capitalize is automatically just making the first letter of the string capital, and then it's getting rid of all the other capitals. So it doesn't necessarily help us if we've got names in our strings. The capitalize method may be a pain. What if I need this to actually be uppercase? I can do that. What if I need it to be title case? Oops, I have to write title. I can do that, and now it automatically capitalized the first letter of each term. What if I wanted it to be lowercase? You get the idea. So we have these formatting methods. Here we go again. We can go down here. We can do favorite color, capitalize, green, favorite color, and green. Green, 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 and green. And notice we had upper. So we can use these methods on a string in a variable as well. So no problem there. Here, input variable for favorite food, display favorite food as all caps, so that's just upper. Here's lower, here's swap case. So you can do that for sure. I think you've got this too, no trouble. Down here we can format string input. So here, notice we can actually we can chain two different things together. So since the input function results in a string, Python will automatically do the innermost operation. It will do this, and then we can chain onto that this method dot lower. So we can go ahead and do that. Favorite color, green. How about that? What if we wanted to actually do a test? And we could do starts with G and run it and do green. It tells me false because we made it lower. What if I did a lowercase g and we type green? Do you see what happened? We can actually chain multiple methods together. Python will work from the inside out. So in that case, it means left to right here. It does this first. It results in a string. Then it applies the lower method to the string. Then it actually tests the string to see if it starts with the lowercase g. And then it tells us true. So we've got some interesting power already that we can do some cool things right off the bat with the code we've learned. So input variable, print favorite color, and we're getting right to the end of module 1. We're going to learn one keyword that really can be used to do powerful things. So down here you can see we can set up a menu that has certain items, and then we can test if pizza's on the menu, and we can see the answer is true. We can go down here and test if hello is in the greeting. This in keyword is doing an awful lot for us. What does it do? In tells the Python runtime engine to go to this variable and go through the whole thing and check for a match of this input, hello. If it finds lowercase hello inside of the greeting, it will say true. If it doesn't, it will say false. So all of that happened just due to this keyword. Remember, there aren't that many keywords, so if we go back to the cheat sheet up here, we're learning them one by one slowly. And you notice the reserved words in Python. We just saw true. We just saw false because we learned booleans. We've now seen in. So there's some others here that we're going to learn, but you can see there really aren't that many. There aren't that many. So we're learning a few right off the bat here, and we're not going to learn all of them just in this basic beginning, but you already have some powerful capability. And this in keyword is one of them. You see that? And so here you can see we can, just like we did a minute ago, we can make our test removing the case sensitivity. So we can see that if we look for a lowercase hello in the greeting, we see that it's not there because this is uppercase. The uppercase hello is there, but when we test using the dot lower, it changes the greeting to lower, and then it checks if it makes the string lower, which it already was, and it says true. It is actually there. So we've got some pretty good power there. And then down here you can test for these various pieces. This is a little preview of what the required code for module 1, that's the part you turn in for a grade. This is a little preview of that. So you can go ahead and do that piece now, and I think you're ready to make this program, which is very similar. You'll add to the menu, you'll test add to the menu. So there you go. And then finally at the bottom here, let's run it. And we have a name error. Red is not defined. Do you see the problem? We're referring to it as a variable, but we need it to be a string. So I need to put this in quotes like that. And now it says true. You know what else I could have done? I could have defined a variable named red. That would be fine. I could do red equals red even. And that works. That fixes the error. But I can't refer to red without quotes around it because there's no variable named red. And that's what Python expects if it's not in quotes. So that's why if I have this, sorry, I've got to restart Python and clear the output because I already ran and put red into memory. So let's do this a different way. Green. I get a name error because green is undefined. And the error points me to what I need to know. And so here you can see it. It tells me to go over here and that I have a problem. And then if I think and I remember the rules of Python, I can fix the error. If I got stuck, I could take a screenshot of this and post it to the Teams discussion and ask if others have ideas what I've done wrong, and somebody will help. That reaching out aspect is very much part of the skill set I want you to build and learn how to do as part of how you become an effective application developer. So happy coding. This is module 1. It is the longest module, but it also is the foundation for your ability to build forward. And I know you can do it. Get through it. Replay as necessary. Come back to this video if you need to. And I look forward to your success. Take care.